If you reduce the number of vertices of a convex polygon P by 20%, the number of diagonals also decreases by 37.5%. How many vertices do we have? Okay, well, first, the number of diagonals, denoted by D, is n times n minus 3 over 2. So if I multiply both sides by 2 and distribute the n over here, we have n squared minus 3n is equal to 2d. Now the problem said to decrease the number of vertices n by 20%. That means we have 80% left. So instead of 1n, we have 0.8n. And then we decreased the number of diagonals by 37.5%, which means that we're left with 62.5%. So if I multiply both sides by 2 and distribute the 0.8n, I end up with this equation. So now I'm left with two equations, two unknowns. The way I'm going to solve this is by making a substitution. So let's first solve for d in the top equation as n squared minus 3n over 2, and that goes over here in for d. Now 1.25 over 2 gets distributed to the n squared and the negative 3n. And so we bring everything to the left, subtracting by 0.625n squared, adding 1.875n. We then factor the 0.015n, and we're left with n minus 35. That's equal to 0. If we set each of these factors equal to 0, you get that n is 0 and n is 35. But because we said P is a polygon, it doesn't have 0 vertices, so the correct answer is 35.